Yeah. Hi guys. Good morning, all of you. Can all of you can hear me, guys? Anyone? Can you please confirm? Is I'm audible?
Yes, sir.
Yes, Vamsi, we
Right,
can hear.
guys. Yeah. Okay. Thank you. So, guys, hope all of you have attended the last session. Can I just let me know, guys, like anybody has joined for the today's class? If anyone has joined for the today's class, if today is your first class, so that I can explain you like what has been happened in yesterday's session. Anyone joined for the today's class? Hey guys, all of you have joined in yesterday's session. Anyone has joined for the today's class? If today is your first class, let me know. Okay. Yeah, I joined. Okay, I have joined. Okay, who is this? Farna. Okay, fine. Let me know, guys, so that I can explain you like what has been happened in yesterday's session. Okay, so one participant has joined today. Okay, Swarna. Okay, fine. Any others else, guys? So I can see 12 participants are there.
Vamsi, I have joined today.
Okay, today joined. So two. Fine. Okay, no worries, guys. Who has been joined for the today's class? Don't worry about that because just a one demo, one just it's an introduction class only. Like we didn't even started with the even we didn't started with any main important concepts. It is just only like an basic introduction we have been done, guys. That too, it is an introduction part only, just to discuss to make you understand like what exactly in data science we do. Even that also we didn't discuss about completely, guys. Just an introduction part only we started, like what is our course content, and apart from that, like what exactly data science is going to be. So some simple techniques only I have been discussed in the yesterday's class. So this is the yesterday's discussion, guys. Whatever I have written there, you can see there. So it is generally I call it as my whiteboard. So you can see the just like in a whiteboard, I have written these particular applications, like what is data science. Okay, so anyhow, I'll just conclude the concept for the today's class once again quickly, like what you are going to get from our side: daily recording videos, whatever the class notes, whatever the coding part we have written. Along with that, you also going to get free Python videos also. We are going to get you are going to get. It is going to be a self-learning, guys. It's a self-learning Python videos. Python videos are self-learning. Remaining are going to be instructor-led classes. Main data science classes are instructor-led classes only. And apart from that, I told you like what you have to do every day. You have to attend 1 hour, 1 hour, 15 minutes of session, 1 hour practice for whatever I discussed in the class, plus another 1 hour. It has to be research from your side also, like self-learning. I'll share you some different blogs, reading the blogs, reading some, going through some videos. Whenever I find some important videos in YouTube or something in the internet, I'm going to share you those materials, so you have to learn some extra things from there also. From there you have to extract it, guys. So that is what we have been discussed in the last class. So just for a quick understanding, what is data science? I have just given some idea about this, guys. So data science is nothing but just in an easy way to make you understand that. Like I'll tell you one small simple scenario also. I'm going to explain it in the today's class. I'm going to explain it, guys. So we have some problem statement. What is the problem statement is, so it is going to be the problem statement. So just let me take some simple problem statement. So easy to understand. I have taken a very small problem statement, guys. That is nothing but the banks are giving the loans to various customers. Okay. Banks are giving the loans to the various customers, but some of the customers are paying the EMS promptly, and some of the customers, most of them, 80% to 85%, they pay the EMS promptly only, guys. Remaining 10-15% only, they don't pay the EMS promptly. They don't pay the EMS promptly. So our target is very simple. I want to identify. So after giving the loan, anybody can say, for example, once the bank gives the loan, so if the EMIs, if the customer is paying the EMI promptly, he is a non-defaulter. If he didn't pay the EMIs promptly, he is nothing but he's a defaulter who is paying promptly. Here the non-defaulters. After giving the loan, anybody can say whether he was a defaulter or a non-defaulter. But our requirement here is before giving the loan itself, before the loan approval only, we want to predict, guys. You know that what is meaning of prediction? Before giving the loan itself, we want to predict whether the customer will be a defaulter or whether the customer is a non-defaulter. Hope you understood my problem statement. So I want to predict. So what is the chances? 80%, 90% chances that this customer will be a defaulter. 90% chances that this customer is a non-defaulter. So we don't want to get again exactly that he is a defaulter or non-defaulter. What is the chances? So before giving the loan to a customer itself, the bank want to do some analysis. So these features, if these particular characteristics like age, salary, what is his expenditure, whether he was married or not, something like that. So our target variable, our target is nothing but to find out whether the customer is going to be a defaulter or a non-defaulter. We want to predict, guys. That is what we want to do that. How can you predict before giving the loan only? How can you predict whether the customer is going to be a defaulter or non-defaulter? How can you do the prediction? So the simple task is nothing but analyze your past customers data. So you have the past customers data is there. If you study the past customers data, you will find some kind of an pattern. You will find out some kind of a relationships. That means whether the customer status will be a defaulter or a non-defaulter will be depending on, if you analyze the data, you will depend on that. For example, let us say that whenever we analyze it the data, for example, whenever we analyze it the data, the customers who are the defaulters, their ages, if I find that, just an example, I'm saying that if the age is between 32 to, for example, 38, for example, let us say that the defaulter's age is between 32 to 38. Let us say that. That does not means that we always have 32 age is always defaulters only. We also have non-defaulters also. But whenever I pick the 32 to 38 age, 80% of them are defaulters. For example, whenever I pick the age of the customers who are between 32 to 38 age, 80% of them are defaulters. Then I can understand that, yes. So whenever the person age is between 32 to 38 years, 80% chances that he is a defaulter. He is a defaulter. Let us say that whenever I find some pattern in the defaulters, let us say that who are staying in the rent, who are staying in the own houses. Whenever they are staying in a own house, again I find that 90% of the people who are staying in the own house, they are the non-defaulters. Then I say that when a customer is staying in a own house, 90% chances that he is a non-defaulter, but 10% chances that he is a defaulter. So finding this relation between whether he was a defaulter and what type of house he was staying. Whether he was a defaulter, what is the age of the person. So finding this relationship between these particular variables only is what is our problem statement. That is what is our solution to a particular problem statement, guys. As I told you in the last class, so whether the customer is a defaulter or a non-defaulter, this is we are trying to find out. This is what we are going to call it as our dependent variable. Our dependent variable. Here the age is what we call it as independent variables. Even the type of the house is also my independent variable. Why? Because the dependent, you know what is the dependent variable? On what? He is dependent variable. On what factors he is depending? On what features he is depending? They are called as the independent variables. So finding the relation between this independent variable and dependent variable is nothing but our main task in our data science, guys. Our main task in the data science is just to get, so we are going to use further, don't think that directly we'll find the relationships. There are so many different types of methods, methodologies. We are going to be using a different type of processing techniques. We are going to learn some different types of mathematical and statistical methodologies and techniques. We are going to be using a different types of algorithms. We are going to be using a different type of systems. Finally, our target is to nothing but I want to find out based on what is the dependent variable and based how this dependent variable is varying with respect to the independent variables. So I'll tell you, humans can't do that? I'll explain. Today I'll tell you one small example for that. So for this finding this one, we are taking some help of the machines we are taking it, guys. We are taking the help of the machines. Instead of you trying to find out the relations, we are giving this data to the machines. Machines are going to learn and they are going to tell you how that particular data is going to be varying. So this module or this particular task is nothing but what we are going to call it as a machine learning. Machine learning is one part of basically, as part of our data science course, we have to learn machine learning. Okay, as part of our data science course, we are going to be learning something called as an deep learning. As part of our data science course, we are going to learn something about the NLP. So all these are some of the subsets or the core concepts of your data science course, guys. Okay, so to make you understand this concept, so little bit, maybe a little bit confused, like what exactly it is. To make you understand, I'll tell you one simple practical example to make you understand the concept. Just an example, guys. For example, let us say that, for example, we know that like whenever I take an Uber ride, or it may be if I book a Uber or a Ola or some other, we know that online cabs. So whenever I book a cab, so that I have a doubt. For example, somebody has got a doubt. How the price, how they are charging. So there are going to be charging. So something every time whenever I take a cab, so there are charging different amounts, not the same amount. So every day I'm traveling from my house to my office, same distance, same route, everything. But on one day, they says that it is 50 rupees. Some days it says that 120 rupees. Sometimes it says 140 rupees. Sometimes it says that. But whenever the distance is the same, whenever I'm taking the same type of a cab, why these particular charges are changing? Just an example. Let us say that I made some data, guys. Like, for example, every day I have been traveling like distance. So how much distance I'm traveling, how much price they are charging, how much amount I am paying, guys. Just an example to make you understand the simple, easy way to understand it. So distance and the price. For example, guys, let us say that I have traveled, for example, let us say distance in kilometers, price is in Indian rupees. Distance is 6 kilometers. Let us say that they charged me 60 rupees. When I travel for 8 kilometers, they charged me 80 rupees. Just an example, simple data only. So whenever I travel for a distance 5 kilometers, they are charging 50 rupees. When I travel for 3 kilometers, they have charged me 30 rupees. Whenever I have traveled for 10 kilometers, they have charged me 100 rupees. So I've taken 5 different rides. Each ride is of a different distance. So whenever I traveled for 6 kilometers, they charged me 60 rupees. For 8 kilometers, they charged me 80 rupees. For 5 kilometers, 50 rupees. 3 kilometers, 30 rupees. And 10 kilometers, 100 rupees. So here, our target variable is our price, isn't it? So what we are trying to study? We are trying to study how this price is varying with respect to the distance. This is what you want to study. Mathematically, you will represent like this, guys. Y and a tilde symbol with the x. Y relation with x. Y relation with x. Here y is the price. X is your nothing but your distance. Price is the dependent variable and distance is going to be the independent variable, because price is depending on the distance, or distance also depends on the price, but price is going to be depending on the distance. If I travel this much kilometers, so this is going to be, or if you want to pay 60 kilometers, 60 rupees, you have to travel for 6 kilometers. Both are interrelated. But our target is to find out what is the price if I travel for this many. Here the pattern is very clear pattern, guys. Everybody can identify that, isn't it? Everybody can identify the pattern without any calculations, without doing any mathematical calculations, we can solve it. What is the pattern, guys? Very simple. Price is equal to, yes, guys, how much is the pattern? How the pattern was there? Price is equal to distance into, yes, anyone, guys? Yes, anyone? Can you please respond? All of you are there, guys? Can you hear me? Yeah, please respond, guys.
10, 10,
Yeah,
10.
10. It is going to be 10. Okay, it is going to be distance into 10. Very simple pattern and very easily. I don't require any machines. I don't require any expertise or any expert or any theories or any mathematical formulations. It is very simple. So our simple target is to find out the price with respect to the distance, guys. Now the idea here is whenever I ask for example, whenever I ask some person, let us say a person in the Uber, so a person who is working in the Uber. So let us say that when I asked the person, they said that, yeah, Yes, please guys, please just give me 2 minutes of time. I'll be back. Just a small work. Just 2 minutes. I'll be back, guys. Please, all of you. Yeah, guys. Yeah. Sorry, guys. I just got small 2 minutes work. Yeah. So let's continue, guys. So, for example, let us say that. So I asked a person in Uber, so like how they will charge us. They said that they said that our price is not only depending on the distance, it also depends on other factors also, guys. Let us say that. Let us say that. So this time again, I'm taking some data, guys. Like same distance, I'll take it, but I'm going to take some other factors like the person saying that who is working in the Uber is nothing but domain expert. He was into that. He was working in the Uber, so he knows how the charges will be taking place. So he said that it not only depends on the distance, it also depends on other factors like whether it is a peak time or not. So there is an another column called as an whether it is a peak time or not. Yes or no, 1 or 0. 1 means it's a peak time. 0 means it is a non-peak time. So sometimes you know that no. So peak time. So whenever there is a huge demand is there, generally they call it as an peak time. And whenever there is not that much demand is there, there are the non-peak times. Not only that, even it also depends on some duration of the drive also. Like distance is in kilometers, peak time, whether it is yes or no, and the duration is going to be in minutes. So what is the price? So this time your price is not only depending on a single factor called as a distance, it is also depending on some other factors also. It is going to be depending, guys. It is depending on some other factors also. It is going to be depending, guys. Okay. So how that dependency is there? For example, let us say that just I'm not making too much complicated so that you can understand that. So let us say that same distance is 6 kilometers. Let us say that it's a peak time. So S1 stands for, let us say, peak time. And duration is going to be, let us say that it is 40 minutes is a duration. So they have charged somewhere around 105 rupees. They have been charged, guys. They charged 105 rupees. Whenever I travel for same 8 kilometers, but it is not a peak time. So it is 0. Peak time, not peak time is 0. and at the duration is 20 minutes, they have been charging me 90 rupees. Same, which is going to be I travel for 5 kilometers. Let us say that is also non-peak time. It's a 0. And I travel for 30 kilometers. So they're charging me 65 rupees. Same, I travel for 3 kilometers. Let us say that it's a peak time. And I travel for example, 24 minutes of time. And they have been traveled for, they're charging me 67 rupees of 67 rupees. Okay, see the difference, guys. 3 minutes, 3 kilometers, 67 rupees. 5 kilometers, 65 rupees. Why? Because there is a peak time. So during the peak time, the charges will increases. Now, same 10 kilometers, but non-peak time, and he has traveled for which is going to be 60. So it is going to be, to make it easy, I have given a simple pattern only, guys. I didn't given any complex pattern. So this is our data, guys. Just an example, this is our data. So whenever I prepared, previously when I prepared the data, so this is the data, I got it. So easily I was able to find the pattern. So price is equal to distance in 10 kilometers. But after some days or after somebody said that, no, it is not only depends on the distance, it also depends on the other factors like peak time, duration also. So let us prepare the data, guys. Now I want to find out. So this time, guys, price is not only depending on only distance. Distance is 1x, let us say x1. Peak time is x2. Duration is x3. Your price is y. So this time, your y is not just a function of single variable x. It is a function of x1, x2, and x3. That means your factor, whatever the target variable is there, whatever the dependent variable price was there, it is not only just depending on only on a single factor called as a distance. It is going to be nothing but x1, x2, x3. There are three factors are there, guys. Okay. So anybody can tell me, guys, can you find out how the price is varying with respect to the distance, peak time, and duration? How it is changing? Can you explain how the relation was there? Can anybody, guys? It's a simple pattern only. I didn't take any much complex pattern. It's a simple pattern only. Anyone? Easy. It's a little bit easy only, guys. You can identify very easily. Yes, anyone, guys? Can you do it? If you see some numbers, it's very easy to identify, guys. Very easily we can identify that. It's almost all same pattern only, but we added some extra patterns. Yes, guys. Anyone? Try. Just try it.
Means peak time is high, the price is increasing, right, sir?
Okay, increasing. But how much it is increasing? Can you identify that? It's not complicated. I don't want to make it. It's a little bit simple. If you see some numbers, easily we can understand it. Easily. It's absolutely, if peak time is increasing, if peak time, it's increasing. But how much it is increasing? Can you explain?
Around 10.
It's not around 10. Okay, observe carefully that can you find the last record? Can you find the last record if you find out? Easy to understand that. See, just to make you understand that for 10 kilometers, just an assumption, for 10 kilometers, they charged 130 rupees. Normally for 10 kilometers, earlier they charged 100 rupees. Now for 10 kilometers, that is, if observe carefully, for 10 kilometers, when I travel for 60 kilometers, sorry, 60 minutes of time, they charged 130. So I can assume that, can you assume that like for every 1 kilometer, there are charging 10 rupees. According to that, how much it must be priced? 10 into 10, it should be 100. That 10 into 100 plus 100. Plus extra, they're charging me 30 rupees. Why they charge 30 rupees? Because peak time is not applicable to here. Because 60 minutes is there, they are charging 30 rupees. That means we can say that they have charging 50 paisa for each and every minute they are charging it. For 60 kilometers, they charge it. Automatically 60 into 0.5 is 30. 30 plus 100 is going to be 130. Okay, whether it is correct or not, let us find out. Whether it's correct or not, we'll find it off. See this. Let us, our assumption is correct or not. Immediately, I cannot say that. With one number, I cannot confirm that. Now check it out. They travel for 8 kilometers. 8 into 10 is equal to 80. Plus, they have been traveled for 20 kilometers. Sorry, 20 minutes. 20 minutes means it should be half. half of that. It is going to be 10 rupees. So it is going to be 90 rupees. Yes, it is matching. Now you can easily understand that. So now tell me, for 60 kilometers, for 6 kilometers, how much they should be charged? 60 plus, for duration is going to be 40 rupees, 40 minutes. So 20, it should be 80. So, but they have charged me 105. 105 means it is going to be 105 minus, which is going to be 80. That means they are charging 25 rupees extra whenever it was a peak time. That means, simple to say that the price is nothing but here equal to what is the distance into 10. This is how the equation, guys. Distance into 10 but plus whether the peak time, what is the peak time, into 25. What is peak time into 25? If peak time is 1, add 25. If peak time is 0, don't add any 25 extra. Don't add extra 25. Mathematical representation. Plus the duration into, which is going to be 0.5. This is the pattern what I can find it of. Is my correct guess? Distance into, that means they are charging 10 rupees for every 1 kilometer. If it is a peak time, they will add extra 25 rupees. So peak charges are 25 rupees. It's a standard. So it's a constant. If it is a peak time, they will add 25. If it is a non-peak time, it will add 0. That's it. Plus nothing but depending on the duration of the time, how many minutes you have traveled multiplied by 50 paisa. If I travel for 20 minutes, they will charge 10 rupees. If they travel for 60 minutes, they will charge 30 rupees. Isn't it? So here, being this pattern was developed by me. See guys, this pattern who gave you guys, this is not the Uber's data. Just easy to understand. I formulated and given you only to make you understand that. I was able to explain that pattern very easily. But sometimes these patterns are not that much easy to decode. These patterns are not that much easy to decode, guys. Then in that case, what we are going to do, guys, we are going to feed this data to the machine. To the machine, I'm going to feed this data, guys. Then the machine is going to tells me how this particular y is varying with respect to the x. That is what exactly the machine learning talking about. So what is machine learning says that you feed the data to us. We are going to analyze the pattern. So past customers data, you give it to me. We are going to analyze the data and we are going to tell you how that particular status, that means whether the customer is a defaulter or a non-defaulter, how it is varying with respect to the features, we are going to explain. So we are going to explain how that particular target variable is varying with respect to the, which is going to be the dependent variable. That is what the machine learning talks about. So machine learning, what is all these techniques we are using, guys? Finally, our target is to find out how this particular dependent variable is varying with respect to this particular independent variables. That is our target, guys. Then what we are going to do with that? Once you know the pattern, what we can do? Easy. Once if you know how that particular customer's default status is changing, how it is depending on the various factors, if you know that, easily we can decide to whom I have to give the loan, to whom I should not give the loan. Easily we can do that. Let us say that, for example, in medical diagnosis, guys, in medical diagnosis, example, we can talk about that. So a person is going to be, a person has gotten, for example, like a person is getting a chest pain. So when the person getting a chest pain, he went to the doctor. He went to the hospital or he went to the doctor. He has been diagnosed with some, all chest pains are not heart attacks, but some chest pains are non-heart attack, not non-heart related issues. And some of them are going to be heart related issues. So once the patient has went to the hospital, they have some collection, they collected some data. Like what is his blood pressure? Okay, let us say what is going to be sugar levels and what is for example, some other cholesterol level, something they have been collected. And finally, their status is there. The status is nothing but whether the diagnosis is an heart attack or whether it is a non-heart attack. Let us say positive, negative, we'll call it as. Let us say that a patient has came, his blood pressure is going to be something by, let us say 143 by, for example, 90. His sugar levels are going to be something like 148 or something. And cholesterol levels also, different cholesterol levels will be there. I'm not talking about that. So diagnosis is positive. That means he is an heart attack. The chest pain is coming, whatever the chest pain he is experiencing, he is a positive. Like that. Again, some more data. So he is negative. It is not a heart attack. It is positive. It's an heart attack. It's a positive. It's an heart attack. A negative, non-heart attack. Something like that. We have the data here now. Now, if you study this data, easily we can diagnose this. Like this particular diagnosis, whether it is a positive or negative, is really depending on a blood pressure. So if the blood pressure is high, and if cholesterol levels are high, and if something like sugar levels are less than this, it is a positive case. That means we really don't require a doctor to diagnosis. Obviously, in diagnosis, doctor is a final decision taker. So it is going to be, he will decide it. But by using this, once if you give this data to the machine, machines can easily detect, guys. That means once if you know this application, I can devise. Nowadays, you got the small medical devices also we got in, guys. So once if I know this particular pattern, I can develop a small medical device where it is going to, once, for example, a person is experiencing a heart attack. So he's having a doubt whether to go to the hospital, whether not to go to the hospital. Immediately take the blood pressure. So if the device has been kept on some body part, immediately it will identify the blood pressure. Now, easily we are able to measure the diabetics, whatever the sugar levels at home itself. So take a small blood, whenever we have a blood sample is there. So take it. What is the cholesterol levels? Identify that. Immediately the device will tell immediately whether that particular person is, whatever he is experiencing is a positive, whether it is a heart attack or whether it is a non-heart attack. If it is a heart attack, immediately rush to the nearest hospital. Isn't it, guys? It really helps you a lot, isn't it? So I have a device which can identify whether the diagnosis is a heart attack or not. So simple device, a small device was there at home. So you can just put it on a body part, blood sample, within a few seconds of time, it can tell you whether the diagnosis is a heart attack or a non-heart attack. If it's a heart attack, immediately rush to the hospitals. Okay, even if it's a non-heart attacks also, because machines also do some mistakes. Machines also do some mistake. Even 1% mistake is there also. Out of the 99 patients, maybe one patient may die. But it's going to save a lot of it's going to be saving the life of the people here now. So that is the main aspect of this particular data science curriculum, guys. So almost all in every, I'm telling about only few examples, guys. We really have a lot of examples we can do that. With respect to the business scenarios, with respect to the medical diagnosis, with respect to some lot of research that are taking place. So in all these cases, these particular, whatever they're talking about the data science has become a very integrated part of them. Almost all in every domain, this particular data science was implemented. Wherever you have the data, wherever you want to understand the data, it is going to be data science. So for example, whether it is in a mechanical field or it is going to be chemical, guys. For example, if I talk about some kind of this, what we can call it as the medical related companies. So which are going to be drug manufacturing related companies. Obviously, they requires a data science because they knows that if this is a medical composition, so we are not experts in that, but whenever this is a medical composition, so this is going to be the reaction. If this is a medical composition, this is a reaction. So once they study that particular data, they will come to know that, yes, this reaction is due to this particular so-and-so component. If this component value increases, the medical reaction also is increasing. How much it is increasing also, it is going to telling you. How much it is increasing, it is going to tell you. Like for example, let us talk about the cancer. For example, there is a medicine was there. So if I increase this quantity by this much, then automatically cancer can be increased, it has been cured by 50% more. So something like that, they have to know the relationships, guys. So those particular relationships only is what the data science is going to identify. Simple to say that, identify the patterns inside the data, which normal humans cannot identify that. Just now I've shown you, this data I've shown you. So simple data I have given you. But as a human, it is a little bit. If I give you another 10 more minutes of time, obviously you can also do that. But I explained you also. So once I explained you, next problem, you can solve it very easily. But whenever the data is a very complex pattern, whenever the fields are not just 3 fields, 4 fields, we have 20 dependencies are there. We have a 20 factors, we are having a dependency, x1, x2, x3, up to we have x20 is there. Then it is impossible for a human to do that. Maybe an expertise can do, but he will take some little bit time. But feed the data to the machine, machine is going to do it in few seconds of time. A few minutes of time is sufficient to study the pattern. That is what the data science we are going to be doing. Okay. Yes. Yes. Okay, fine. So that is going to be the one what we can say that, guys, right? So that is a basic idea about how we are working with this particular concept of the data science concept, guys. Okay, so it is quite interesting. It is a quite interesting. So obviously you will be having a doubt. Real, can I do this? Absolutely, we can do it, guys. So just to show you, don't worry about the coding what I'm going to write in, guys. I'm just showing you the code how we are going to do that. Don't worry, just a few 2 minutes time. It won't take that much time, guys. Same data set I will prepare, guys. Same, whatever the data set I told you, same data set I'm going to prepare it now. So I'll open one Excel sheet, guys. I will open one small Excel sheet. It's a simple Excel sheet I'll open. I will feed all this data into this machine, into this notebook, guys. Okay, what is the first one, guys? It is we taken now, it is distance. Don't worry, just try to understand what I'm going to do, guys. Whether it is a peak time or not, it's a peak time or yes or no. What is going to be the distance? Not it's an travel time, which is going to be what is going to be the time duration we can take, and what is the price, guys. So what we have taken, guys, distance is 6 kilometers. The peak time is S, and he's going to be travel for 40 minutes, and he has been taken 105. So generally, this data set, I'll use it for every batch example. That's why I can easily remember the data. 8, which is going to be 0, because I know the data here, guys. 20 minutes. So they will be charging 90 rupees, guys, right? 80 plus 10. Okay, 90, right? Next one, 5 kilometers. It's a non-peak time. They've traveled for 30 minutes and they have been charging 65 rupees. Okay, next one. It is going to be 3 kilometers. It's a peak time, travel for 24 minutes, and the distance they charged is 67 rupees. Finally, just now we have seen now 10, 0, he has been traveled for 60 minutes and they have been charged, 60 minutes. And they have been traveled for, they charged around 130 rupees. This is the data what we have been given, guys. This is the data, small data set, guys. If really, if we have hundreds and thousands of records, we can't do it, guys. We can't do it. Okay, simple. I'm going to save the file, guys. I'm saving the file. Let us say that I'm saving it. Let us say in one small folder, guys. In a C drive, I have a data folder. Let us say that I'm going to save it like an Excel sheet. The name of the file is going to be, let us say, something called as an uber.xlsx file. Okay, if you want the Uber data, guys, you can get the Uber data, guys. If you want to get the Uber data, guys, I'll show you the Uber data. So some partial data may be available. So we'll import these data sets later, guys, not now. So there are some different platforms are there, guys. There are different platforms, online platforms from where we can get the data, guys. I'll show you the Uber data set. If you want, we can see the Uber data set, guys. So you see my Uber drives data set, Uber fares data set. Open this Uber fares data set, guys. So from this data set only, I just explained, but this data set contains lot of data, guys. This data set contains lot of data, but I have data. I have taken the data is a very small data only. I have been got taken the data. How many records it contains, guys? If you see the data set, they will tell you how many records it is going to be gets contained. See, these are the columns, what we have them, guys. What is the fare amount? What is the pickup date time, passenger count, pickup longitude, pickup latitude, drop off longitude, drop off latitude. So it won't depend on longitude or latitudes. Based on that, they have to calculate some information. So this is the data set, guys. This is the data set what we are having, guys. So we have the data here now. I think we are having some how many records we are having here now. It's not a small data set, guys. We have a large data set is there. Okay, so that's why if you want, you can get the data sets later. Later, we are going to do the Uber fares analysis and all these things. If you go to YouTube, you can find a lot of videos, guys. If you just go to online and verify the Uber data analysis, you can find a lot of videos. You can find it off, guys. Check it out in the YouTube. Okay, this says that Uber price it is going to be analysis. Uber price, which is going to be user price, which is going to be analysis, guys. So try to find out. We can find out lot of examples. We can find out based on that. You can really find out lot of examples based on that. So you can just check it out. Maybe we didn't search it properly. User, which is going to be price, which is going to be analysis. What we can do that. You can see forecast. It is going to be forecasting something. We'll see that later. We are going to see the applications. You can here only we can find out lot of data. We can find it off, guys. We can find out lot of data. We can find it off. There are so many people who has done the research. We can see that. Uber phase predictions, Uber phase amount predictions, Uber fare price predictions. A different people has done the coding, guys. If you want, you can go through their notebooks and we can verify that. So this is going to be the coding, what we can do that. I'm not taking any complex example. If you want, we can see the applications later. Can you observe carefully? Just they have been got some kind of an formulation. They written some code. Okay, how the data was there. They have done some process, guys. It's not directly they are not doing it. They are finding some outliers. If there are outliers are there, what they have to do, data and times, pick up and drop of columns, data visualizations. See, guys, lot of data is going to be there. They've done a lot of analysis on that. Okay, so this is going to be ride versus time. So they have been having some relation. This is a visualization which will tell you how the two variables are related, guys. Wherever the relation is more, we'll get a dark color. It's called as an heat maps. There are called as heat maps, guys. These heat maps will tell us like how the two variables are related. So these variables are highly correlated, guys. What are the particular variables? It is going to tell you. Just don't worry. So I told you, there are some statistical numbers are there. Correlation matrix is going to be there. There are some techniques. These are all standardization is a technique what we are going to use. And they have been applied this application. So see, this is going to be the one what we can see that. This is going to be one, it is going to be showing you guys. Final how the graph was there. All these things we can see with the data. It's not directly feeding the data, guys. We have to identify what are the different issues are there. So we have to do all these applications. So don't worry. I'm not going up to that much complication level. I've taken a very simple data set only. So just observe the steps, guys. That means machine learning and data science means so many people are having the idea that we are going to write a lengthy scripts. We have to write a complex codes. We don't write that much, guys. Simple, very easy and very simple coding only we are going to write, guys. So first of all, I have to import some libraries, guys. One of the library I require is to read the Excel sheet is pandas. One more, which is going to be for my machine learning, I'm going to be using a library called as an scikit-learn. sklearn dot, which is going to be, we call it as linear models. Don't worry. So what type of algorithm? Somebody has asked me yesterday, how many algorithms we are going to learn? As I said that, don't count it, how many algorithms we are going to be working. It is our idea here is our target is to nothing but how to study this particular algorithms. So here we are studying what we are studying here, what you are going to learn tomorrow in our coming days. Obviously new algorithms will comes, guys, no doubt at all. Whenever a new algorithm comes, how to study that particular algorithm. So that is what is our basic target here, guys. So whatever the algorithm I'm implementing here is, it's a linear regression algorithm. How do you decide that it's a linear regression? That we'll understand it, guys. It depending on the target variable, we'll decide it. Our target variable is a numerical value. So it is a linear regression models, what we do that. See, guys, I'm going to read the data. How I'm going to read the data, if you see, guys, I'm going to be reading the data from Excel sheet. C colon dash data slash, it is going to be uber.xlsx file. This is your data, guys. Uber equal to, do you want to see the data? This is your data set, guys. This is your data set, guys. Got it? Simple. Distance, whether it's a peak time, duration, price. I'm not writing any complex code, guys. So don't think that all this coding, these are not coding, these are not logics, guys. There is a predefined function is there. Do you want to read the data from Excel sheet? Read dot, which is going to be Excel, read underscore Excel. Now, who is y, who is x, guys? Y is equal to nothing but, I'm deciding the y. Y is nothing but Uber of, which is going to be the price is our y variable. Who is your x here now? Your x is equal to nothing but it's a Uber of 3 columns I'm taking. One is the distance, one is the peak. I don't study the data, guys. I'm not going to study any data. I'm not going to write any code at all. Machine is going to tells me. So this is our x and y, guys. I given that. Now simple example, guys. Don't worry. Model is equal to, don't worry. Just how many lines of code I'm writing, observe carefully. Even if it is a complex data also, the same thing, guys. Model.fit, which is going to be x comma y. Done, guys. Machine learning is over. Machine learned the data, guys. That's it. I never written any code saying that distance into 10, peak time into 25, plus what is the duration into 0.5. I didn't written any code, any logic, nothing is there. Just I taken the price, I taken the distance, peak and duration as the our features. I feed it the data, guys. X and Y, machine has learned. Yes, what the machine has learned, can you show me? Yes, model dot, these are called as coefficients. That's it, guys. Same quotient, whatever I have been explained, same quotient, it is going to be doing that. But see, we expected one relation, guys, but the machine has expected a different relation. It has been identified, guys. Okay, so don't worry, because our expectation may be different, but finally the result is going to come, guys. The result is going to be gets coming. It is going to be model dot. It is going to be intercept also. I didn't talk about this intercept, but leave it for the timing, guys. Leave it for the timing here now. So just a given correctly only. Just a minute, guys. Distance, price, duration, model equal to linear regression, model dot fit. Did I given correctly only?
Peak is not used.
Okay. That is the reason. Okay. So we given price wrongly. Okay, sorry guys. It's a peak. That's the reason why it has given a difference. So machine is learning. Even the machine has learned also, guys. That's the reason why I can't see the intercept properly. This is the data, guys. Right. Perfect, guys. Now. So see, guys, the quotient for distance is 10. The quotient for peak time is 25. The quotient for duration is going to be 0.5. Perfect, guys. So that means that it is saying that this price is coming by multiplying the distance by 10 units, peak multiplied by 25. Peak means 1 and 0. 1 means it is add 1 into 25 is 25. 0 into 25 means 0. So if it is peak time, add 25 extra. If it is non-peak time, add 0. Duration multiplied by 0.5, guys. You can ignore the intercept value. See, guys, perfectly we have got what we expected only. 10, 25 and 0.5. Observe carefully, guys. Machines are learning, guys. Machines are learning here now. I didn't written any code. Observe carefully. I know where I written the code. So who is going to do? This algorithm is going to do, guys. This algorithm knows how to solve the problem. Then how I came to know that I have to use this algorithm? That is what we have to learn here, guys. For which problem statement, which algorithm? That is what we have to find it off, guys. Okay. So that is going to be the one which we can see as of this particular application, what we can do that. Okay, so that is the basic idea about this, the particular technique, what we are going to be doing it, guys. Okay, so that is the idea about the machine learning algorithm. So see, guys, how simple coding have been done. Even if you see this code also, guys, not my code, you see any code, wherever the machine is learning, if you observe the code, they will write the same code as it is they are going to write, guys. They will write the same code as it is they are going to write it, guys. Yeah, just give me a second, guys. I just got a call. Just a minute. I'll got a call. Just give me a minute. Yeah, let us go here, guys. So if you observe carefully, guys, they also do the same thing, guys. They're also going to do the same thing. If you observe these 2 lines of code, guys, observe the 2 lines of code. See this particular 2 lines of code, guys. They are written the same as it is, guys. SQL learn dot linear models import linear regression. It's a linear regression. It is going to be, don't worry about that. X train, Y train, they are going to do, guys. What is the accuracy of this model? The accuracy of the model is going to be 80%. So their model accuracy is 80%, guys. Don't worry. What are that particular applications? Later we are going to see about that. Okay. So this is going to be all about the concepts of how we are going to be gets working with this particular techniques, guys. So this is what exactly this concept of machine learning. Even if the data is a very large data set, even if the features are very huge features also, machine learning syntax is only this only, guys. Your machine learning syntax is going to be only this syntax only, guys. That is what we can talk about those particular applications here now. Okay, so that's it, guys. This is going to be all about how we are going to be gets working with these particular applications, guys. Okay, hope all of you understood, guys. Like, just don't worry about that, what I have done. But I think you can understand the procedure of machine learning, guys. We taken the data, we loaded the data, we identified your y, we identified your x, and we have given the data x and y to the machine. Machine studied the data and giving how they are varying here now. So clearly it is telling me the pattern. This is a pattern of your data. That is what we can identify, guys. Right, guys? Anybody? Any questions here, guys, if we have? Anyone, guys? If you have any questions, I can just take up some few questions and I can go ahead, guys. Right, guys. So this is what exactly the machine learning is going to be talking about. So don't think that I've taken a very small example. So, but when you go to real applications, even if you take some complex data, I think you got some idea about by looking at this notepad, whatever the notepad I have shown you here now. So if you can observe carefully, guys, they're implementing some statistical techniques. Already I told you. So let us talk about the data sets. Let's take the data sets. Let me again go for the Uber data set, for example. So a lot of people has contributed to that. You can also do this. I'll tell you what is this Kaggle and all these things. I'll tell you about that. So these are the data sets, guys. And here also we have a different notebooks are there. Check it out. What are the different notebooks we can see? Different people has written. So they are writing, comparing some best ML models. Uber fair prediction, they are going to be doing it, guys. Data set is the same. They are doing, guys. So see, they are doing some exploration of the data exploration they are doing. Okay. After that, they are going to be doing some kind of an EDA, exploratory data analysis. These are all some kind of a skills, guys. After that, some kind of a processing they have been applying. See, they're applying some kind of a pre-processing. What they are doing, we'll study that later, guys. Don't worry about that. What is encoding? All these things we are going to do, guys. So these are going to be some kind of a final data set is there, and some kind of a data manipulation they are doing that. There are going to be some methods, guys. Standardization of a training data set, how to try standardize. Why should they try standardize? We can see that. I told you know how the feature selection, feature extraction is taking place. Heat maps. There are going to be some kind of an heat maps they have been got plotted, guys. Correlations. We can see the heat maps. Can you see? It is an heat map, what we are going to call it as. So what skills you require, you understood now, guys. You require some mathematical and statistical concepts. We require some kind of an pre-processing techniques we require, and some manipulations we require. And apart from that, we also has to require some kind of a visualizations. These are all visualization, guys. They will tell you how they have been related. They will tell you. Okay, so see, there are going to be different types of. Finally, if you come here, again, finally, the same technique they will apply, guys. So they will apply different techniques, what we are going to see. So simple coding only, guys. It's not a complex coding, but it is going to be simple coding only. They are going to be doing it, guys. So these are all the basic different ways how we are going to be gets working with that. We'll study about that. Whatever I showed you is that this one only, guys. So can you see, guys, y is nothing but your dependent variables. X is going to be nothing but your independent variables. So just now I shown, B naught, they are calling it as a B naught. So beta naught or B naught, what they call it as, they are called as intercept. The factors B naught, B1, B2, all these are going to be what we can call it as. So B naught is an intercept, B1, B2, B3, all these are going to be comes under the BI, what they are calling it as the quotients. What are the quotients I shown you, guys? See, the coefficients of the regression model are found to be, they are showing the same coefficients, guys. So this is how exactly we are going to be gets working with this particular data science course, guys. So coding part, you can ignore it. Coding is not an important here, guys. But understanding all that particular mathematical techniques, all the mathematical the applications, that is going to be most important, guys. Remaining things are going to be coding part. They are very simple. You have seen the code now, how I implemented the coding. For every operation, there is a simple syntax will be there. Do you believe this, guys? Just only these lines of code is machine learning. A simple machine learning model it is. I trained the model here, guys. Model was trained here now. Model is learning. Your machine learning model is going to be learning from the data. It learned the data. I didn't written any code. I didn't said anything. Simple, I feeded the data and asking the machine, please learn this. with the help of this regression model. So the regression, whatever the linear regression model was there, that will help the machine to study it. That is our main aspect of the data science, guys. Okay, so that is going to be, so it is a very small example. We can also train the machines by giving some images. I'll give the images to the machines, guys, with the human faces, and I will ask the machine to identify whether the person in the image is a male or a female, guys. Understood? I'm going to give the images and I'll ask the machine to learn whether this person is a, I'll tell that this image is a male, this image is a female. I'll explain the machine. I'll tell that this image is a male, this image is a female. It will study that. And whenever I give a new image, the machine can tell you whether the person in the image is a male or a female, guys. So machine requires some training. Machine requires some learning. That is our main important aspect of this data science, guys. It needs some training, guys. So the machines are capable to learn. Now the machines are saying that for everything you need not to instruct us. For everything you need not to write any coding. We are capable to learn. We got the ability to learn by ourselves. That is what we are calling it as AI. That is what we are calling it as AI. Machines has got the artificial intelligence. Previously, they don't have any brain. Previously, we used to say that no, guys. The robots and machines don't have any brain. They cannot think. They cannot decide. They cannot take a decision. Everything is going to be based on our instruction, our coding, what we have given. So what the machines are saying now is, we got some intelligence. That is not natural intelligence. It is artificial intelligence. Artificially, we got it. So humans are having natural intelligence. Machines will have artificial intelligence. We are capable to learn. We are capable to study. We are capable to analyze the data. We can study. We can take our own decisions. So you feed me, you give me some training. Based on that particular training, I'm going to study that. That is how the humans learn, machines also learns, guys. Over that time period. Only the difference is machines requires more and more data, guys. Machines requires a more and more data it is going to be requires. Just like I can say that a small kid, for example, a small kid. So let us say that a 2 years or a 3 years, a kid was there. He cannot differentiate between a male and a female. He cannot differentiate between a male and a female. So for example, if I give some training, this person is a boy, this person is a girl. So what is his learning is, the girl is having a long hair and a boy is having a short hair. That is what the kid is going to understand. If I show some let us say I shown two boys and I said that these two are boys and these two are girls, then the child is going to understand that, okay, girls are having long hair and boys are having a short hair. That is what his interpretation. We don't teach him anything. We don't teach anything. Now, whenever I bring a boy who is having a long hair, the kid says that he is a female, he is a girl. Why? Because he only imagines that, okay, if they have a long hair, then there are girls. Whenever they have a short hair, there are the boys. That is what the kid learns. Same as it is, machines also learns. But how much extent the machine is learned, we have to evaluate also. Whether it is correct or not also, we have to specify that. That is your training phase. If you observe there, in some data sets, we can see that X train, Y train. So we are giving some training, guys. So, but machines cannot do I can also feed the same data to machine. But only with 2 female images and 2 male images, machines can't study. Maybe I have to require somewhere around 20,000, 30,000 images. If I give, machines will learn perfectly. If I just give 3 images and say that these are males and these are females, machines can't learn properly. It requires more and more data for learning, more and more data for which is going to be training. That means more and more examples they require, guys. Then only the machines can learn perfectly. Even if I give 10 images, 5 females and 5 males, machines will study, but not that much efficiently. Not that much efficiently they will study that. If I give some 10,000 female images and 10,000 male images, then the machine is going to learn perfectly, guys. That is what exactly we are talking about that machine learning concept, guys. Okay. So hope you got some little bit technical knowledge for today, guys. Understanding, not technical knowledge, I think you have understood some technical concepts as part of the today's class, guys. Yesterday, it's a little bit theoretical class. Maybe you didn't understand that much. But today, I think you got some idea like what you are going to do. So we are going to learn different algorithms. Different, just like how we studied the linear regression. I'll explain how it is working. I'll explain it. What is the mathematical background behind that? What are the different process we have to do? What are the different methodologies? What is the standardization? I'll explain all these things when you go to the real practical applications, guys. Okay. So that is going to be just this is my second demo session, guys. So I don't want to put more on the demo sessions. Just it is going to be a few introduction part only I want to do that. So I'm not taking much time. But once my regular classes starts, I'm going to start with the main classes. Then a complete session will be there, guys. Okay. So that is about my second introduction class, guys. So in first introduction class, I explained you like what we do it in data science. Second class, how we are going to do that in the data science. Same example I shown you a little bit practically. Tomorrow, I'm going to tell you a little bit more and more factors, like what are the steps we have to involve all these things. And so that we'll get some idea about why we are learning data science, what our clients will expect. Whenever you go to the real time, yesterday somebody is asking me, like, will you develop are you going to develop any applications like Windows applications, web applications? We don't develop any Windows applications, web applications, guys. Our main target is to train a machine learning model. My main target is to train a machine learning model. So whether the model is learning correctly or not, how much extent it learned correctly, that is our main concept here, guys. Once if it is ready, using that, I can make the predictions. I can make the predictions based on what the model has been learned. Okay. So that is about my second session, guys. Yes. Yesterday's session, yeah, no worries, guys. You will be getting a follow-up mail from my backend team, guys. Okay. So I'll just show you the link. If you want, I can share you the link also. Okay. Anyhow, no worries. You are going to get a follow-up link from my backend team. So we'll get a follow-up. Today you attended the demo, right? So you will be getting a follow-up mail we are going to get like this, guys. This is a follow-up mail. There you can see the demo video. It is uploaded to the YouTube. If anybody has missed the yesterday's class, guys, don't worry. You will be getting the link. You will also get the link, guys. So this is the link. Yeah, guys. So this is yesterday's session, guys, which I have taken. So I have just shared the link. Anyhow, don't worry. You will also get the link, guys. So this is my session yesterday, what I have been explained. And this is the discussions, what we have been done in the yesterday's class, guys. Same thing, whatever I have written yesterday, same thing, you can see it on the screen, guys. Okay, fine, guys. So this is a link, guys. You can just get the recording yesterday, one session only. So you can just go through them. Okay. So that's it for my second class, guys. So almost all I have taken 1 hour, almost all more than 1 hour I've taken. So anyhow, guys, just because they are demo classes, I don't want to just take more and more technical aspects. Just we are in the very introduction part and very first basic levels only we have been started. So hope all of you got some little bit idea, guys, like what we do it in machine learning, what we are going to do it in data science. We are going to learn a different techniques we are going to learn, guys, to solve a real-time problem statement with the help of some kind of a machine learning algorithms. Those machine learning algorithms are going to study the data and they will tell you how that particular y and x is going to be interrelated, how they are related, how they are varying. That is what the information will get it, guys. Okay. So that's it for the today's class, guys. So if you have any questions, we can have discussion. I have 10-15 minutes time is there it. So you can spend some time, guys. I can spend some time. Yes. Anyone, guys, if you have any questions?
Hi, this is Raj.
Yes, Raja.
Yeah, can we customize the existing algorithms? Is there any possibility?
Yes. It's every algorithm is going to be, see, every algorithm is we don't have. So for example, just to make you understand that. So whenever we talk about, just a second once, let me open the same one. So it is going to be obviously every algorithm is going to be works within your control only. It is going to works. Got my point? So even the algorithm is learning, or even the algorithm is going to be gets learning that. So it is not going to be, it's not going to be works directly by itself. We are going to also have some customizations. I didn't use them. But if you open this linear regression, if I check it out, you will be having some kind of an parameters we are going to be having. In this case, in this linear regression, we don't have that much customizable. But whenever we go to some other algorithms, like for example, I'll tell you some algorithm, like from sklearn dot, there are called as decision trees. Import, there is an algorithm called as a decision tree algorithm is there. So if you see the decision tree algorithm, if you can see, yes, you can see a lot of customizable parameters will be there. Lot of customizable parameters. Within your control only, it is going to work. So we have to study what is this criterion equal to. We have three criterions are there. A Gini index, we have an entropy, we have a log loss is there. So the documentation will be available here now. Criterion equal to Gini, what is entropy, what is log loss. What are those? We will study that. Next, what is going to be the split? Max depth equal to, what is the max depth represents? What is the minimum sample for splitting? What are maximum features? What are going to be maximum leaf nodes? What is minimum impurity decrease? What is going to be class weights? So by according to this control only, your algorithm is going to work. So customization means we cannot change the algorithm process, but within some customizable parameters only, I can say that. So yes, you can learn up to this extent only you learn. Don't go beyond that. So within our control only, it is going to work. So this is what we call it as customizations.
Got
Okay.
it. Thanks.
Yes, guys. Any others, guys? If you have any questions.
Sir, in that output, the distance and peak and duration time is there, right? The distance is 10 and the peak is 25, sir. Or
Yes.
how we can
Peak is?
No, peak is 0. In table we defined as zeros and ones.
One means yes, one is a peak time because it's a mathematical calculation. No, I cannot say yes or no because it should be 1 into, see, it is 1 into 25. 1 means what is the 1 into 1 means? 1 means it is a peak time. 0 means it's a non-peak time. Okay. So what is meaning of peak time now? 1 into 25. That means you're adding extra 25. What is a non-peak time? It is 0. 0 into 25 is 0. That means compare with the non-peak times, the peak times are having 25 more. That is what it is going to say about.
The duration is 0.5 hours.
0.5 into the duration. That means we can say that they are charging 50 paisa per 1 minute. For 40 minutes duration, 40 into 0.5. How much? 20 rupees they will charge.
Okay.
Got it, isn't it? So it is 6 into, if you observe carefully, 6 into 10, 60 plus peak time 25, 85, 85 plus 20, which is going to be 105.
Sir, we can't see that formula, sir, here for that any method.
Which method? Formula, direct formula. You have to write the formula. Machine is going to tell us that this is the data. Now you can write it. So 10 into this particular column, and which is going to be 25 into which is going to be this column. We'll do that. That means directly we are not going to do that. We are having some other techniques are there later. That means in our main classes, we do that particular formula. Formula will not be shown. It only tells you that this is going to be. But whenever I plot the data, then you can see the data here now. Plotting and all these things are extra required. Then you'll understand the concept.
Okay, sir.
Okay, fine. Categorized algorithm in ML like Java, we have a do you have a categorize? It's not categorize. We call it as an classification algorithms. Swarna, we call it as classification algorithms. We are going to call it as regression algorithms. We are going to be calling it as it's what we call it as classification algorithms. Okay. Right. So like that, guys. Yeah. So that is going to be the different techniques, guys. Anyhow, we'll work on all these applications later. In the remaining classes, we'll start with that. So tomorrow also, I'm going to take one more demo session, guys. That is nothing but related to something like what technical aspects we have to do. Okay, so what basically we have to do in real time in a data science project, what are the implementations we have to do, what skills we have to require, what skills we have to implement. So that topic, I'm going to take it in the tomorrow's class. With that maximum, you can get some clarity about whether you can take this course or not, whether you are really fit to this course or not. Okay, how much extent you can learn, all these things you'll get some clarity about that. Then from the next class, that means from the Monday's class, generally Saturday we don't have a class, tomorrow is a Friday, so I'll complete of it. And then I'm going to start the regular classes from the Mondays onwards. I'm going to start with that. Okay, so tomorrow I have the class as usually, guys. Tomorrow is also demo session only, so we'll connect tomorrow at the same time with the same link, and we are going to further have a small discussions. I'll clarify all your questions, and from the Monday's class we'll start with our regular classes, guys. Right? Anyone, guys? Any questions if you have?
Hello, sir.
Yes. Yeah.
Sir, this is Vishwas. I
Yes,
had
yeah,
just
Vishnu.
one question.
Yes, yeah.
Why we are using different types of graphs?
Different types of graphs. Because why you use a different types of graphs means, see, like for example, maybe you have an idea about that, like what is scatter plot and what is a bar plot. Do you know the difference between what is a scatter plot and a bar plot generally? Do you remember it?
Yes, we have read that in statistics.
Yeah, okay. So we learn in statistics. What is scatter plot is going to be shows you. Scatter plot is going to shows you like how the two variables are related. It's we generally at school level what we think is, okay, data points are plotted, that is it will tell you the relationship between the two variables. So here if I plot the data, I can understand. For example, if I here also I can plot the data. So I'll say import, which is going to be matplotlib dot, which is going to be pyplot. For data visualization, we'll use this library. Now see, I'm going to be plotting the same data here now. PLT dot, which is going to be scatter plot. I said X is equal to, let us say, what is the price? What is the distance? We'll say Y is equal to nothing, but it is a price. And data is equal to nothing, but it's a Uber. And I'll say PLT dot show. So why do you do this one is basically to understand how that particular data is related. You can see the data here now. So if you observe carefully, peak times, non-peak times, depending on that, because it is not depending only on the distance. It is also depending on the other factors like what is the duration, whether it's a peak time or not. It depends on that also. So how these particular two variables are related, we are going to use it. Why do you require a bar chart? Bar chart is basically to know, like for example, how many, let us say how many writes has been taken at peak time, how many writes has been taken at non-peak time. If you want to know that, then I'm going to use, just show me, let me show you, it's Uber dot, which is going to be, what is the, we have a column called as in peak. It's going to be, we have a column called as in peak time dot, which is going to be value counts. Just an example. Don't worry how I'm doing that. Dot, which is going to be plot dot, which is going to be bar. So if you see this particular bar, so what I'm trying to do here now? Bar charts. Why I'm using the bar charts? Basically to just to know which one is going to be the count. So if you can see, these are going to be one peak time and these are zero. These are non-peak time. How many are there totally? Three peak times are there, two non-peak times are there. So bar charts, why do you require? Bar charts are basically used to compare the quantity, whereas the scatter plots are used to understand the relationships. Like that, some advanced reportings like heat maps are there. They are going to tell you how the two variables are related, which variables are more closely related. We use as the heat maps. With the help of heat maps only, most of the things are done in the machine learning. Got it?
Yes.
Yep. We have a different types of plots, like how to understand the distribution of data. Box plots are there. Like that, different plottings will be there basically to understand them. Yes, I think somebody also having some question. Somebody is asking some question. If anybody, guys.
Yeah, hi Vamshi.
Yes, hi.
How's our flow will go? Like you mentioned 2 weeks will be Python, right? So
Yes, yeah,
can you
yeah.
just give little detail about it? Like, so first will be Python, what will be the next? And I mean,
Yeah,
over
I
the
think,
4-5 months.
Yes, yeah, sure. I have already, I think, already have shown that in the maybe yesterday's class. I have shown that. So once again, I'll show you. No worries. It is going to be. Just give me a second once. Just a minute once. Just give me a second.
Sure.
Let me put it on my desktop. Yeah. So this is our plan. So this is going to be our plan. So you can see this is going to be our plan of our actual plan of learning. So first we are going to start with core Python. Then we are going to move to some fundamental concepts of our data science like NumPy, pandas, data visualizations, then machine learning with included with R, deep learning applications, NLP. Plotly and the dash we are removing, guys, because it is not that much important. And even we have decreased the duration for the Hadoop and Spark also. Hadoop and Spark, how to develop the chatbots using NLP, and some concepts of Azure ML. And lastly, we are having the Power BI. So this is our total course curriculum. And you can also see like how we are going to be performing. You can see the tech. You can day wise, like first day what we are going to discuss, second day wise whatever this, but they are not fixed like a corporate training. 12 means it is not 12 days. It may be extended to 14 days also, 15 days. It is an approximation only. Don't think that we have given only 12 days. So are you going to cover only for 12 days? No, we are going to discuss. Extend depends on our discussion. It will be there. But generally, if the time period is 1.5 hour time, 1 hour 20 minutes, if I take it, absolutely it will take us 12 days. It is sufficient for that 12 to 14 days. Hardly you can say that 2 weeks of time. Okay.
Okay.
So
Thank
these are
you.
all topics are there, right?
Thank you.
Yeah, guys. That's it, guys. Let us end the session for today. So just for today, we'll end up the session for today, guys. And we'll meet up in the tomorrow's class. Hope I'll see you all of you tomorrow, guys, at the same time and same link, guys. Thanks all of you for today.
Thanks.
Thank you, guys.